Hello, Honors Chemistry, and welcome to the last of Chapter 7, 7.10, Classifying Chemical Reactions, where this is just a summary of everything else in the chapter, right? So, to date, this is what we've talked about, right? We've talked about the fact that chemical reactions can be divided into different types, right? Precipitation, where in precipitation we have two aqueous reactants, right? And then we switch our cations, right? We have acid-base reactions, right, where again we see an acid and a base, right, acid and base, and then we switch our cations. And then we have our gas evolution reactions, which are often a subset of acid-base reactions, right, where we have acid and a sulfide, or a carbonate or bicarbonate, or a sulfite or a bisulfite, right? Or we have a base and ammonium, right? And all of these, same principle, right? We are going to switch the cations, right? And again, bearing in mind that we have those special substances, right, where our H2CO3 and our H2SO3 both decompose to form water and the respective gas, either CO2 or SO2, right? And then we have our oxidation reduction reactions, wherein they often involve an element on the reactant side, right? An element reactant, right? And if there are two elements, all we're going to do is put them together in some logical way based on our rules from Chapter 5 and write a formula for it, right? We have our combustion reactions, which are going to be either CH or CHO compounds, right, plus oxygen, and they're always going to give us carbon dioxide and water. Okay, so that's a summary of the reactions that we have covered, okay? Alternatively, right, some books will classify them based on what the atoms are doing, right? In that we can have some atoms, right, where we have A and B, and they come together to make a new compound, AB, right? Oh my gosh, that's what we just talked about with our redox, right? That's basically a redox process, right? Decomposition, right, we talked about that a little bit in the context of either our H2CO3 or our H2SO3 breaking down, and that's what this does, right? Where we have one reactant that breaks it into smaller, simpler reactants, right? Single displacement we didn't really talk about. That does fall under the realm of redox, in that we have an element, right, which reacts with something else, and we might add to that in a little bit. I'm not sure yet. And then double displacements, right, which if we look at this, right, so we have something that's labeled AB, something that's labeled CD, and on the product side, oh my gosh, all we've done is we've switched our cations. So now that A is stuck to D and C is stuck to B, this is, right, the principle for our precipitation and our acid base and our, what's that other one? Gas evolution, right? So really, the classifications are almost irrelevant, right? We're all talking about the same types of reactions. So what that means is on a larger scale, right, this double displacement really just envelops all of these, right? And if we go on the other side, right, oxidation, reduction, combustion actually involves all of these, right? So it doesn't really matter how we classify them, right? They're all the same is the point, right? So should you go to college and decide you want to take some more chemistry and you're like, well, these aren't classified the same way, but they're all the same reactions, right? And again, we're just studying a tiny, tiny subset of the reactions that sort of fall in line with the things we've already learned, right? So that way we can sort of keep layering on the stuff that we know, right? Okay, so thank you for listening. This is the end of Chapter 7. All right. This is very important because obviously from here we will build in Chapter 8 and talk about layering on quantitative aspects to our chemical reactions. All right. Thanks for listening. Be good, and I'll see you soon. Bye.